Alkaline earth metals, and I've been saying all along, they are group 2 elements. Group 2 elements, and a chemical family name for them is alkaline earth metals. The word earth has to be there. Group 2. So starting from beryllium to magnesium to calcium to barium. I don't know. Let us check. Beryllium, magnesium, calcium, strontium, barium, and radium. Yeah, these are group 2 metals. Yes, group 2 metals: beryllium, magnesium, calcium, strontium, barium, radium. Okay, I was just but I noticed that they are ending with beryllium, magnesium, calcium, strontium. Okay, with that I think you say they are rhyming, but it is also the case in group 1. They are lithium, sodium, potassium, rubidium, calcium. Okay, okay, that's it. We are at alkaline earth metals. Also, we'll be checking on these properties. For this group now, we'll be checking on these properties, the energy levels, the atomic and ionic radii and its comparison, ionization energy, that one about heat, electric conductivity, and reactivity. So, we'll be starting with the first one, of course, energy levels. Energy levels. And that, let us compare it by just drawing the atoms of an atom of beryllium and an atom of calcium and see how do the energy levels compare. But even without drawing, we know that beryllium has a configuration of, it is atomic number 4, 3, 4, a configuration of 2, 2. Calcium is atomic number 20 with a configuration of 2, 8, that is 10 plus 8, 18, 19, 20. 2, 8, 8, 2, that is calcium. So let us, okay, so without drawing, but I want to draw since it will help us all through as we discuss the other properties. This one has 2 energy levels. This one has 1, 2, 3, 4. This one has 4 energy levels. Magnesium is atomic number 12 with a configuration of 2, 8, 2. It has 3 energy levels. So in short, the energy levels increase down the group. That way, we said that we discussed down the group instead of up. Down the group, the energy levels increase. They increase by 1. In the case 2, other elements below calcium in this group, that is random, is it random or radium? Okay, we have strontium and barium. They have more energy levels as compared with these 3. We have said even if we know that, let us just do the 2 atoms, that of beryllium and that of calcium. Beryllium atomic number 4, configuration 2, 2, that is the nucleus. I write beryllium, and then I'll be writing, okay, I'll be drawing 2 energy levels. That is the first one and the second one, and then you can indicate the electrons, 2 and then 2. Done. Let us go to the atom of calcium. Atomic number 20, configuration this, 1, 2, 3, 4 energy levels. I start by the nucleus, I write calcium, and then I show 4 more energy levels. Not more, 4 energy levels. 1, 2, 3, 4. 4 energy levels. Let us show the electrons. 1, and then, sorry, 2, 8, 8, 2. That is 2. Let us go to it now. 1, 2, 3, 4, 5, 6, 7, 8. 2, 8, 8, 2. Another 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 2. 1, 2. And that is the atom of calcium. Atomic number 20. The configuration is here. So first, you have already concluded on the energy levels, and now we'll be going to the atomic and the ionic radius. Let me write the configuration here. Beryllium 2, 2. Calcium is 2882. Good. Now, the question is, okay, we are done with the energy levels. We are going now to atomic radius, and I'm happy now I won't be defining some terms that you already defined when we are discussing alkaline metals, because we defined terms like ionization energy. We defined how they lose electrons. Okay, we discussed how they lose electrons. Just a reminder, we have discussed how they react by losing electrons, and some more other terms that I won't now dwell so much in. So from here now, we have looked at energy levels. Let us go to the atomic radius and then to ionic. And for the atomic radius, we see it is the distance from the center of the nucleus to the outermost energy level. Outermost simply meaning the one at the edge, at the end. So we want to compare the atomic radius for beryllium and that of calcium. We can do even the atom for magnesium, but now there will be an increase in size. They follow the same trend. That is how we used beryllium and magnesium. Now, from the center of this nucleus to the end, that will be the atomic radius. The same case to calcium, from the center to the edge. And which is greater? It is calcium. Yes, calcium is greater, or it is bigger. The reason we said you have to state first which is greater. Calcium is bigger. Reason, it has more energy levels. And the conclusion will be the atomic radius increases down the group. The arrow shows down, increases down the group due to an increase in energy levels. Increases down the group due to an increase in the number of energy levels. That is enough for 2 marks. Yes, increase down the group, 1 mark. Or maybe if they awarded 1 mark for it, then there should be a half and a half. But now I think the examiners should be a bit fair. So we learned these things, yes. We just never woke up, or maybe we are not born in this. So increase down the group, 1 mark, due to an increase in number of energy levels. Another mark. It's so simple statements, but conveying the whole message. Yeah. Atomic radius done. Let's go to the ionic radius. And when we talk of ionic radius, what comes into our mind is that we have now to form ions from the atoms that we have. You first think of the atom, now think of the ion. How is the ion formed? The process involved, and now you can discuss the ionic radius. We say that these metals will form ions by losing electrons, and that happens to to all metals, whether it is in the first 20 elements or not among the first 20 elements like copper. It will be forming ions by losing electrons, and therefore all metals are positively charged. The ions of all metals, they are positively charged. Might it be copper 2 plus, zinc 2 plus, lead 2 plus. You know them? Yes, you know them. So all of them form ions by losing electrons. We have beryllium here. Yeah, we have beryllium configuration 2,2. It will be forming an ion by losing 2 electrons, and therefore it means that 1 energy level will be lost, and the ion will look like this. Beryllium, it had a configuration of 2,2. Now it has only 1 energy level with 2 electrons. Calcium the same. It forms an ion by losing 1 electron. this one is lost. And therefore, the ion of calcium has 3 energy levels. Calcium ion, 2 plus, 3 energy levels. 1, 2, 3. No, I have to draw it to be smaller than this. I don't want it to look larger, so that you can show it even in our diagrams what we mean. Yes. Sorry for that. Calcium, it lost 2 electrons. Now it is 288. 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, and then another 8. These ones are lost. For it to form an ion, 1, 2, 3, 4, 5, 6, 7, 8. That is the resulting structure of the ion. We want to see the trend in the ionic radius. How do you compare that of beryllium and calcium? How is the comparison? Which is bigger than the other one? Calcium is bigger. Yes, calcium is bigger than that of beryllium. And you expect that magnesium, which is in between these two elements, will have a bigger one than beryllium but smaller than calcium, since it will be having, it has a configuration of 2H2. It will use 2 electrons to form 2H. It will be having 2 energy levels. Therefore, the ionic radius increases down the group, increases down the group due to an increase in the number of energy levels. Because the ion of beryllium, 1 energy level. Ion of magnesium, 2 energy levels. Ion of calcium, 1, 2, 3 energy levels. Therefore, the ionic radius increases down the group due to an increase in the number of energy levels. Done with that, the other part in the same category is comparing the ions to their atoms. Let us compare their ions to their atoms. How do they compare? Is it the ion which is bigger than the atom, or the other way around? We have that of beryllium. Beryllium has a configuration of 2,2, that is the atom of beryllium, and the ion of beryllium, the beryllium ion, has a configuration of 2. This one has 2 energy levels, this one has 1 energy level. And the question becomes, we are comparing their atoms to their ions, and we want to conclude for the whole of the group. How does it behave? So it will be a conclusion on that their atoms, their atomic radius are greater than the ionic radius, or something like that. But it's a conclusion for the alkaline earth metals. Yes, and we will say that their ions has a smaller ionic radius than the atomic radius. So in this case, we won't be saying that down the group or up the group, because we're just comparing. There's a comparison between atoms and ions. So this one is bigger than this. The conclusion is, you know it by now. Now you have to do that in words now. That is true. And in words, we say that the atomic radius of alkaline earth metals atomic radii of alkaline earth metals is bigger than the ionic radius of ions of these alkaline earth metals. The atomic radii of alkaline earth metals these ones, is always bigger than the ionic radius of the alkaline earth metals. It seems to be a repetition, than the ionic radius of their ions. The atomic radius or the atomic radii of alkaline earth metals, these ones, is bigger than the ionic radius or radii of their ions. These ones is bigger than this, and that is just a we have just stated, and the reason is they form ions by losing electrons, and therefore the atoms have more energy levels as compared to the ions. We can just put it in writing. They form ions. They form ions by losing electrons. I'm using that for electrons. They form ions by losing electrons, and therefore loses energy levels, and therefore atoms have more energy levels. Atoms have more energy levels. Yes, atoms have more energy levels than ions. So for the case of beryllium, the atom has 2 energy levels, the ion has 1. For the case of calcium, the atom has 4 energy levels. Yes, for the ion has 3 energy levels, 2, 8, 8. For the case of magnesium, the atom will have 3 energy levels, the ion will have 2 energy levels. And therefore, comparing the atomic radius to the ionic radius, the atomic radius is always bigger than the ionic radius for alkaline earth metals. And this is because the atoms have more energy levels by one. The atoms have more energy levels than their ions for each and every specific element. So this part, we have just completed it. The atomic radius, the ionic radius, and then comparing the two. We have seen the trends in atomic, increase down the group, ionic, increase down the group, and then comparing atomic is bigger than the ionic.